Welcome everyone. In this video we are going to be looking at using and understanding the multimeter. If you do find this video informative, visit www.sttsonline.co.za to check out some of the courses we have to offer. Please like and share this video if you found it helpful in any way. It would be appreciated. Also consider subscribing to my channel, so let's get into it. A multimeter combines the functions of several measuring instruments into a single device, allowing it to measure electrical quantities such as voltage, current, and resistance. This versatility makes it an essential tool for electrical testing, troubleshooting, and maintenance. Modern multimeters are highly accurate and widely used in electrical and electronic applications. In the past, analog test lamps were commonly used for fault finding. However, they are generally not recommended for use on modern vehicles and equipment with advanced electronic systems, as they can damage sensitive control units and electronic components. Multimeter care and handling. When using a multimeter, it is important to handle the instrument with care and use it correctly to prevent damage caused by improper use or mishandling. Following the manufacturer's instructions and selecting the appropriate measurement range and function will help ensure accurate readings, extend the life of the meter, and maintain safe operation. Before we look at the multimeter functions, it is important to understand the following concepts. Alternating current, AC. Alternating current, AC, is an electric current that periodically changes direction as it flows through a circuit. AC continuously reverses its direction at a specific frequency. AC is the most common form of electrical power used in homes, businesses, and industrial applications. Direct current, DC. Direct current, DC, is an electric current that flows in only one direction through a circuit. DC maintains a constant flow of electrical charge. DC power is commonly supplied by batteries, solar panels, and vehicle electrical systems. It is widely used in electronic devices and control systems that require a stable and consistent voltage source. The voltage level may vary, but the direction of current flow remains the same. The COM port is the reference or ground connection on a multimeter and is used for most measurement functions. The black test lead is always connected to the COM port, regardless of whether you are measuring voltage, current, resistance, or continuity. The COM port works in conjunction with the appropriate input terminal for the selected measurement. For example, voltage, resistance, and continuity measurements. Black lead in COM, red lead in the V/omega port. Current measurements. Black lead in COM, red lead in the appropriate amp, milliamp, or microamp port, depending on the expected current range. Correct use of the COM port helps ensure accurate measurements and protects both the multimeter and the circuit being tested. Degree Celsius/omega/milliamps input port on a multimeter. The degree Celsius/omega/milliamps port is a multifunction input terminal used for measuring temperature when a compatible temperature probe, thermocouple, is connected. Resistance, to measure the resistance of electrical components, cables, and circuits. Current, to measure small electrical currents in the milliampere range. For these measurements, the red test lead is inserted into the degree Celsius/omega/milliamps port, while the black test lead remains connected to the COM port. Measuring alternating voltage. When the dial is in this position, we measure alternating voltage between 0 and a 1000 volt. Alternating voltage. This setting is used to measure alternating voltage, AC, in the range of 0 to 3000 millivolts. The unit millivolt represents 1,000th of a volt, where 1 millivolts equals 0.001 volt. This range is suitable for measuring very low AC voltage signals in electrical and electronic circuits. Measuring direct voltage, DC. This setting is used to measure direct current, DC voltage within a range of 0 to 1000 volt. DC voltage is a constant voltage that flows in one direction and is commonly found in batteries, power supplies, and vehicle electrical systems. This range allows for the measurement of both low and high voltage DC circuits. Measuring direct voltage, millivolt. This setting is used to measure direct voltage, DC, in the range of 0 to 3000 millivolts. A millivolt is equal to 1,000th of a volt, making this range suitable for measuring very low DC voltage signals in electrical and electronic circuits. Measuring resistance in ohms. This setting is used to measure the resistance of cables, circuits, and electrical components within a range of 0 to 500 megaohms, 500 million ohms. Resistance is measured in ohms and indicates how much a material or component opposes the flow of electrical current. Measuring current, milliamps, amps. This setting is used to measure the flow of electrical current in both alternating current, AC, and direct current, DC circuits, with a maximum measurement range of 10 amps. Current is measured in amperes and indicates the rate at which electrical charge flows through a circuit. Measuring current in microamps. This setting is used to measure the flow of electrical current in both alternating current, AC, and direct current, DC circuits, with a maximum measurement range of 5,000 microamps. Current is measured in microamperes, where 1 microampere equals 1/1,000,000th of an ampere. This range is ideal for measuring very low current levels in sensitive electronic circuits and components. Note, not all multimeters are equipped with a microampere port. When measuring voltage in a circuit, a voltmeter has a very high internal resistance, which prevents significant current from flowing through the meter during measurement. To accurately measure the voltage drop across a component, the voltmeter must be connected in parallel with that component. Depending on the direction of current flow and the meter lead connections, the displayed voltage may be either positive or negative. When measuring current in a circuit. When measuring current in a circuit, the ammeter must be connected in series with the component being tested. This allows the current flowing through the component to pass through the meter, enabling an accurate measurement of the circuit current. Connecting an ammeter in parallel may result in incorrect readings and could damage the meter or circuit. When measuring resistance in a circuit. When you measure this resistance, disconnect the component from the circuit and measure across it. That concludes this video. Thank you for watching.